Grade 10s, how are you guys? I hope you have been enjoying this extended holiday and that you have had a lot of time to rest. You have had a lot of time to rest and that now you are able and have the energy to watch these video lessons that we have decided to compile so that we may continue with the coverage of our syllabus. Okay, but before we get into the subject matter, okay, I would just like to ask you, even though you're not here, how you are coping with this whole experience of the COVID-19. And I would just like to add my own 2 cents to the whole issue by saying this. I would like to say to you guys, let's try to focus on our lives, let's try to focus on our studies, and let's not worry too much about things that we cannot necessarily change. Okay, so I know you guys are grade 10 and you have all this access to all this media, but I hope you're not using that media negatively to say you just wake up in the morning and the first thing you check is how many people have died from COVID-19. Makes no sense. Why would you be looking at that? Even if you see that 1,000 people have died, you're not going to resurrect them. Yes, it's painful, it's sad, but there is no point waking up each and every single day and feeding yourself that same information. I would like to say at this moment, guys, let's try to feed our minds with as much positivity as we can. Let's try to feed our minds with as much positivity as we can. I'm trying to stay positive. I'm here at the school, standing in an empty classroom, just hoping that we can just get past this whole experience and we can come back and learn the way we always used to. Online learning is fun, it's great. I'm enjoying it, being able to shoot videos like this. Maybe I might also become a celebrity. You never know, right? So now let's try to get now into the business of the day. So this is our chemistry lesson, okay? Right, so I'll be loading for you guys physics lessons and chemistry lessons, but this one is our chemistry lesson and this is our lesson number 1. Okay, it is our lesson number 1 with who? Obviously, yours truly, Mr. Marshall A.C. Candiago. Okay, so this is our lesson number 1, and what is our topic for today? Right, I have tried to write the topic and the objectives. Okay, I hope you guys will be able to see. I'm sure you can see the objectives as well as the topic. The first topic we're going to look at is group properties. We are going to look at group properties of group 1 elements. Right? At this point, I hope that everyone is having a periodic table with them. I hope you're having a periodic table. So what are our objectives for this lesson? Right? So by the end of this lesson, by the end of this video clip, when you have watched it and you have watched it again and you have gone through all the material, I hope you will be able to interpret the periodic table. You should be able to interpret the periodic table as a classification, as a method of classifying elements according to their properties, right? So we have the periodic table, right? And you know the periodic table, the way it is arranged. We have talked about the periodic table, how it is groups, how it is periods. We have covered this material. We covered this material when we were in grade 8, again when we were in grade 9. So by now we are familiar with what the periodic table is, okay? So you should be able to interpret the periodic table. You should be able to interpret the periodic table as a method of classifying elements according to their properties. Okay? So you are classifying elements according to their properties. These may be physical properties and these may be chemical properties. I'm sorry, I was just looking at the screen, not into the camera. I apologize. So these may be what physical properties or they may be chemical properties. And it is these properties which then determine in which group or in which period an element is found. Okay? By now we should be comfortable with that because we have dealt with the periodic table several times, right? We have dealt even with trends, right? But we're going to be looking at it today in specificity to group 1. Okay, so we will also be able to outline by the end of this lesson, we should be able to outline the physical and chemical properties of group 1 elements. Okay, so at the end of this lesson, we should be able to look at group 1 elements and say, what are the physical properties of group 1 elements? And you'll be able to see that when we talk about physical properties, we are referring to issues like melting point and even to issues like boiling point, but we're also even issues that deal with states of matter, in which state are these elements found, what is their color. These are physical properties, right? Then we will also look at the chemical properties of these group 1 elements, in which reactions do they take part in, right? And when they take part in a reaction, how do they contribute to the reaction? Do they lose electrons? Do they gain electrons? Okay, so at the end of the lesson, you should be able to describe these physical and chemical properties of group 1 elements, right? As well, in addition to that, by the end of the lesson, we should be able to describe the reactions. We should be able to describe the reactions of group 1 elements with oxygen, right? So we'll look at group 1 elements. I hope by now you have looked at a periodic table and you have looked at which elements are there in group 1. Okay, you have looked at which elements are there in group 1, and you have tried to say, okay, so these elements, when they react with oxygen, we did some practicals, if you recall, when we were in grade 9, where we showed the reactions of lithium with oxygen. I will put those similar reactions again. I will put them into this video as well, so that we may be able to see the colors that are produced when elements such as lithium are burning in oxygen. So we will look at and we will be able to describe the reactions of group 1 elements with oxygen and the reaction of group 1 elements with water. We should be able to do that. Okay, so now let's try to get into the lesson proper. Right. So as always, with all these lessons, there is the video, this one which you're watching, and it has an accompanying set of notes. It is an accompanying set of notes. Please make sure that you already have the notes, you have your textbooks, this material. My job now is to try and explain. Right? I'll try and explain the material, but on your part as the learner, on your part as the scientist, as the chemist, we are in grade 10 now. Okay, we are moving towards grade 11, grade 12, and then we'll go to university. We must now develop that ability to be confident in ourselves, to say, okay, I can also read this material, and I can be able to understand it. Okay, so I'm sure that when I'm explaining this material now, you're just basically trying to tick, to say, okay, yeah, okay, I already thought about that, I already thought about that. So that is what you're doing basically. You're just confirming. I'm just here to reassure and to confirm what you have already studied and what you already know. Okay, so let us not rush through the material. There is no need for us to rush through the material. So in this lesson, I will be rubbing the board several times and trying to write chemical equations for the reactions that we are saying we are going to be able to describe, reactions for the group 1 elements. Okay, so another thing that I want to encourage you is that throughout this series of lessons, there will be times when you just have to pause the video and you do a certain activity that I would say to you, guys, please do this activity. Okay, so you should be comfortable that when I say, okay, pause the video, and I give you a length of time to say maybe pause for 3 minutes or for 4 minutes. Then you pause the video, you write the equations, or if it's an activity that I want you to do, then you do the activity. Do not cheat yourself. I know you guys will be able to follow the instructions properly. So let's look at the group properties. First, we'll look at group properties in general. Group properties in general in reference to the periodic table. So we are saying the periodic table, a method of classifying elements according to their chemical and physical properties, right? So when you are looking at the periodic table, you are seeing that there are groups. Okay, we have elements in group 1, elements in group 2, elements in the transition elements, the D block elements, right? We'll also be looking at the D block elements later, right, in grade 10, as we promised when we were in grade 8, that at some point we'll look at what we call D block elements, and this is now the time. Okay, so we'll look at D block elements as well. So we have group 1 elements, we have group 2 elements, and then we have the D block. We have the D block known as well as also as the transition elements. You would say AKA, also known as D block elements, AKA transition elements, or transition elements, AKA D block elements. Right, so when you move past the D block elements, you then go on to group 3, right? Group 4, 5, 6, 7, and 8. Right, these are the 8 overlying groups that we have on the periodic table. And each of these groups, the elements in each of these groups, they have similarities. They have similarities in terms of their activity, their reactivity. They have similarities in terms of their physical properties, in terms of their chemical properties. Okay, so when we see the arrangement on the periodic table, we just didn't find ourselves with elements being placed haphazardly. There is no haphazard nature to the periodic table. Okay, there is no haphazard nature to the periodic table. Before I even proceed, let us pause this video right at home. Let us pause this video for 3 minutes. Okay, let's give ourselves a chance to just look at the different periods, the different groups that are there. Remember, the groups are the vertical ones, and then the periods are the horizontal ones. So I need you guys to pause the video, then to just go through, just look at the elements, right? Look at the elements, try to see if you can identify any of the elements. Okay, so pause this video right now for 3 minutes, just go through the material, go through the periodic table. Good. Right. I hope we have had a chance to look at the periodic table and to look at the different aspects that are there. Even if it's in group 2 and you find that in group 2 there's magnesium, there's calcium, and you try to identify what are the similarities between magnesium and calcium, you will find that there are several similarities that are there, right, for these group 2 elements. None less than the fact that they all have 2 electrons in their outermost shell, right? And this plays a huge role in how they react and which chemical reactions they take part in. Okay, so the group properties and the periodic trends that we see on the periodic table are based on the chemical and the physical properties. So you will find that elements that are also in the same period, if elements are in the same period, okay, how do you tell if you were just given, let's say you were given an element, you were given chlorine, okay, and you were given sodium, or you are given magnesium, you are given different elements, okay, you are given fluorine, and then you're asked to say which period is fluorine in, which period is chlorine in, which period is iodine in, without having to be shown a periodic table. Okay, I think from the Bohr structures, if you remember the Bohr structures, right, how would you determine which period the element is in? How would you determine it? Think of magnesium, think of lithium, think of beryllium, right? If you're able to know the atomic number, it means you're able to draw the Bohr structure of that diagram, right? So if we think of an element such as fluorine, okay, if we think of an element such as fluorine, how many electrons does fluorine have? We know that fluorine is in group 7, okay, so therefore it must have 7 electrons in its outermost shell, but its atomic number is 9. Its atomic number is 9 for fluorine. So you have 2 electrons in the first shell, 7 electrons in the second shell. That means if it has 2 shells, it must be in the second period. So you must look for other elements. If you have another element and you look and you find that, okay, so this one also has 2 electrons in the first shell and then maybe 5 electrons in the second shell, right? What is that? It's nitrogen. Okay, so these ones must be in the same period. They must be in the same period. Why? Because they have the same number of shells, even though they have a different number of electrons, in the outermost shell, but they have the same number of shells, right? So they are in the same period. Now let's move on. Let's try to move on now to the business of the day, group 1 elements. Group 1 elements. Okay, so at this point again, right now I'm sure I've overlaid this video, and we are looking right now at group 1 elements. We are looking at group 1 elements. So when we're looking at group 1 elements, we would want to know their physical and chemical properties. Right. So the group 1 elements, the group 1 metals, also known as alkali metals. They're also known as alkali metals. Remember, we have alkali metals, and then we have alkaline earth metals being the group 2 elements. Right? So the group 2 elements are known as alkaline earth metals, but the group 1 elements are known as alkali earth metals. Okay? Right? I'm trying to say this as slowly as I possibly can, because I don't want to rush through the material. Right? I don't want to rush through the material. I know you have so much time. You have so much time that is on your hands. So you should be able to just compose yourself right now. Breathe out. Right? Just compose yourself. Look at the material. Try to follow it step by step. We're going to go through each and every single one of these lessons. We'll go through it step by step. Okay? So don't panic. Don't rush. Okay, don't rush. I'm looking at the same notes that you're looking at right now. Okay, so don't worry. I'm going to explain the concept. If you have any difficulties, you just inbox me. You just ask, sir, what did you mean by that particular point? Right. So when we think of the structure of the group 1 elements, okay, so if we have group 1 elements and we have group 1 elements such as lithium, that is a group 1 element. We have sodium, okay? We have lithium, we have sodium, we have potassium. These are the symbols, right? Let me write the words. This is lithium, we have sodium, sorry, I wrote the again with the symbol, because the symbol is just stuck in my hand. Right, so we have sodium. Then we also have potassium. Right? These are 3 common group 1 elements that we know: lithium, sodium, potassium. Right? Let's work with sodium. Right? I think everyone is familiar with the concept of sodium. I keep looking to the screen. I apologize. Everyone is familiar with the concept of sodium because we know that we have sodium even in our table salt. That's the simplest example that we give when sodium reacts with a group 7 element known as chlorine. And this gives us a table salt. This is a table salt known as sodium chloride. That's the salt that we're using. Whether you're frying your eggs, whether you're cooking your rice, you always put a bit of salt, but not too much salt. Salt, they say salt is a silent killer. Silent killer, it's almost like it's an assassin, right? Using a sniper, you can't even tell, right? So don't put too much salt in your food, but that salt is known as sodium chloride. Sodium chloride. Okay, so if we were to recall the structure, let's try and recall the structure of how would we draw the element sodium, right? So sodium, from what I recall, sodium has a mass number. Sodium has a mass number of 11. It has an atomic number of 11, right? It's an atomic number of 11. And if I can place the mass number here and make the mass number 23 and the atomic number 11. 11, 23. Right, so that is the mass number for sodium, and that is the atomic number or proton number for sodium. Okay, so what do we get to know from this mass number and from this atomic number? The atomic number is we are able to use the atomic number to draw the Bohr diagram for sodium. We are able to use the mass number, the atomic number, to draw the Bohr diagram for sodium. Okay, so at this point, you can pause the video again, right? Pause the video again, just for a couple of minutes, right? I need you guys to then go on to write the atomic number and the mass number for lithium. I need to write the atomic number and the mass number for potassium as well. Having done that, I would like you guys, please, to draw the Bohr diagrams, the Bohr structures for lithium and for sodium and for potassium. I will draw the one for sodium here so that we get to have an idea of what we're talking about. So at this moment, if you may please pause the video, okay, pause the video, allow yourself to draw the Bohr diagrams for those three structures. Please, pause the video. Thank you. Right, so now I hope you have drawn the diagrams, the Bohr structures. Let's now look at the Bohr structure for sodium. How do we draw it? Okay, so we know that sodium has an atomic number of 11. The atomic number tells us that it has 11 protons in it. So if it has 11 protons in it, it means because it is a neutral atom, this is the sodium atom, because it is a neutral atom, it should therefore have an equivalent number of electrons. It should have an equivalent number of electrons. Right. So let us draw it. So they have the element sodium, right? And in its first shell, right? In its first shell, we will have 1, 2 electrons, because the first shell can only be occupied by a maximum of 2 electrons, right? You can never put more than 2 electrons in the first shell. Right, now let's go to its second shell. Why are we going to a second shell? Because remember we said it has 11 protons. If it has 11 protons, it means this should be equivalent to 11 electrons. There should also be 11 electrons. There should also be 11 electrons. If there are 11 protons, therefore there should also be 11 electrons, because the atom is neutral. Yeah? The atom is the type of 0, and this positive 11, this negative 11, they cancel each other out. 11 minus 11 is equivalent to 0, and then you have a neutrally charged atom, right? No charge. So now since we have put 2 here, that means we still have 9 electrons that we need to put into this Bohr structure. So now I'll put 1, 2, remember we still need 9, 3, 4, 5, 6, 7, 8. But we need to put 9. But this is now the second shell. And the second shell can only be occupied by a maximum of 8 electrons. Okay, I hope we are together there. The second shell can only be occupied by a maximum of 8 electrons. You cannot go past the number 8 in this second shell. So now we have 1, 2 plus 8, we now have 10 electrons, which means we will still need a third shell. So you drew this third shell. And in this third shell, how many electrons are we going to put? We are only going to put 1 electron. So we now have 11 electrons. We now have 11 electrons on our Bohr diagram. If we were to show the number of protons, this one would be P, 11, and if these ones are neutrons, this would be N. Let's have this one being a small n, so that we don't confuse it with nitrogen. So we would have 12. We would have 12 neutrons, because the total has to add up to the mass number, which is 23. So 12 neutrons, 11 protons, and also 11 electrons. Right, I hope we are together there. So using this information, try to see if you can confirm using a periodic table. Try to see if you have drawn the correct Bohr structures for lithium and for potassium. Check your work. Have you managed to draw the correct structure for lithium? Yes. Have you managed to draw the correct structure for lithium? Have you managed to draw the correct structure for potassium? Okay, good. Right, so now if we look at these electrons, now we'll remember that we talked about ionic bonding and we talked about covalent bonding, right? And we said ionic bonding, this is bonding between metals and non-metals, in which metals donate their outermost electrons to the non-metal. So these group 1 elements, because they have These group 1 elements, they are metals. They are metals. And because they have one electron in the outermost shell, we find that it is easier for them to lose this one electron, right? It is easier for them to lose this one electron. Remember, we discussed this material, we talked about cations, and we talked about anions. It is easier for them to lose this one electron, to donate it to a non-metal which requires, right, one electron or two electrons for it to fill out its most outer shell. Right, so group 1 elements in their chemical reactions, they donate an electron. They lose the outermost electron. Right, common reactions, we will look at these reactions, right, when you have reactions such as the sodium reacting with the chlorine, or the lithium reacting with bromine to form sodium chloride and lithium bromide respectively. Right, those are chemical reactions that are very common for group 1 elements. I hope we are still together. Right, I'll keep on saying this throughout this video. Do not worry, take the time to pause the video. Remember, if we were in class, I'll be checking your work, we'll be looking at different material. So allow yourself to pause the video, right, because the video might be moving a bit too fast. So allow yourself to pause the video and just go through the work. Go through all of it. Just look at it again and again and again and again. You will not be penalized. There will be no punishment. Just allow yourself to get the information as clearly as you possibly can. Right, so now when these elements, when they lose this outer electron, we say now if, let me look for my clothes, just need to find the clothes so I can grab this part of the board and grab this part of the board. Right, so we now have this element, sodium, which has now lost its electron. Remember we talked about ionic bonding. So this is not new material, this is not uncovered territory, we have been through this before. So when the sodium loses its electron, its outermost electron, okay, so it has now lost its outermost electron. It means that previously it was having 11 protons and 11 neutrons and 11 electrons and 11 electrons, and its overall charge was 11, positive 11 and minus 11, which is equal to 0. That was its charge. The positive 11, I hope we're together. The positive 11 comes from the protons because protons are positively charged. The negative 11 comes from the electrons. Electrons are negatively charged. I hope we are getting that part. Let's look at it again. We have protons and we have electrons. This is all happening inside the element known as sodium, right? Na sodium. It has 11 protons and it has 11 electrons. So if we want to find the charge of a neutral atom of sodium, we simply say the protons minus the electrons. So protons plus 11 minus 11 is equal to 0. 11 minus 11 is equal to 0. Simple enough. Now, so when this one takes part in a reaction, right? Let me put this shell, it's still there. This sodium, when it takes part in a chemical reaction, it is going to donate. Right? It's going to donate. It's going to donate this electron to a non-metal. It's going to donate this electron to a non-metal. And when it donates this electron to the non-metal, it means that it's going to be left with how many electrons? Remember, it had 11 initially. It had 11 electrons initially. It has now donated 1 electron to a non-metal. So how many electrons would it be left with? Yes, very simple. It would now be left with 10 electrons. Yes. So, but then the number of protons, what happens to the number of protons? The number of protons does not change. It doesn't change because protons are in the nucleus. Right? Protons are in the nucleus and they are not lost nor are they gained. They are not lost nor are they gained. So the protons do not move. The protons do not move, they don't leave the nucleus. Right. So you have now the charge, if you want to calculate it, because it is now in iron, because it has lost an electron, it is now known as the sodium ion. Okay? It's now the sodium ion. And it still has 11 protons, but now it is now left with 10 electrons. Right? So which means it now has a charge of positive 1. If you say 11 minus 10, you say plus 1. So when you write the ion of sodium, you say Na, and you take this new charge, Na plus 1. Na plus 1, Na positive 1, right? That is the charge of, right? That is the charge of the sodium, okay? So you can just write this Na plus, because usually when it's 1, you don't say anything about it. If it's 2, write as 2, but if it's just a single positive charge, we say Na plus. If it's on the other side of the periodic table, right, and we have now nonmetals and they lose electrons. Remember, we talked about formation of anions. We talked about the formation of anions. Anions are formed when a nonmetal gains an electron, and now it has a greater number of electrons than protons. Okay, so it will then have, let's give an example of chlorine. It forms the ion known as chlorine negative, right? The chloride ion. Chlorine negative, that's the chloride ion. Right. What else can we talk about when we talk about the physical properties and the chemical properties? Right. So another physical property of the group 1 elements is that they are good conductors of heat. Okay. So these group 1 elements, if you go through them, all of them, the group 1 elements, they are good conductors of heat, and they are also good conductors of electricity. Right. I think the moment you just say that they're group 1 elements, remember, we say they are metals. They are alkali metals, and it is a characteristic feature of metals for them to be good conductors of heat and electricity. And the same holds true for group 1 elements, and the same holds true for group 1 elements, right? So we will also see in the video, right? You can see that they are soft. We can see that these elements are soft and they can be cut, right? Even using a knife. You can cut through the metal using the knife. But they are extremely reactive. You will see that if you observe that they are stored, when they are stored in a container, then they have oil that is placed on top. If you're going to have sodium, or if it's potassium, or if it's lithium, if you've seen your reactivity series before, they are extremely reactive, right? They are extremely reactive. So you will find that the sodium, or is the potassium, is stored under a layer of oil. This prevents it from just going on to react rapidly with oxygen, because if it was just to be left outside in the open, it would react instantaneously, spontaneously with oxygen, and then you lose that particular metal. So they also have high melting and boiling points, which in turn decrease as you go down the group. Right, their melting points and boiling points decrease as you go down the group. Why is this? Because you will find that as you go down the group, you will find that the reactivity is decreasing. Right, we would say the volatility, the ease with which the element reacts, is actually reducing. And because the volatility is reducing, it means that also the ease with which you can break them, or in which they can boil, then also becomes more difficult. So their boiling point actually increases as you go down the group, but the reactivity is decreasing. So as you're going down group 1, the reactivity is decreasing, but the boiling point and melting point are effectively increasing. Google the word, search for the words volatility in relation to elements, because this will come into play in group 1. This will come into play when we look also at group 7 elements, right? So even in chemical reactions, if we say the word volatile, so that's a word for you. Find the word volatility, right? Let me write the word here at the top of the board. I hope you'll be able to see it. Let me write the word volatile, volatility, right? Volatile, or volatility, right? So you can Google that word and then you can try to use it. It's just a common English word, and then try and use it in relation to the group 1 and the group 2 elements, as well as the group 7 elements, to see how their volatility increases or decreases as you go down or as you go up the group, right? So there are other physical properties that are there. There are other physical properties that are there in relation to group 1 elements, and you guys will have to basically look for those other physical properties. Some of them are included in your textbooks, but it is necessary for you guys to be able to research in different sources, right? I know you have your living physics, you have your living chemistry, your solid foundations, different textbooks, but now you have a wide array, right? Allow yourself as a student to study, right? If you're a student, you should study. The word student comes from the word study. You have to study and you have to enrich your mind all the time, right? And as you're doing that, always free your imagination. Free your imagination. Imagination is everything. So allow yourself to think outside the box and never limit yourself. Never limit yourself. I'll say this to you, grade 10s, again and again. Never limit yourself. You have so much potential. You have so much ability that is there, stored in your brain capacity. You just don't realize it, right? But you are capable. So search for the different properties, chemical or physical, that are related to this group 1 element. Right. So let us also look at the reactions, right? Let us also look at the reactions of these elements. Let's look at the reactions. Let's look at maybe lithium, how lithium, right, reacts with oxygen. Right. So if you were to have a reaction, because we say by the end of this lesson, we should be able to describe how the group 1 elements react with oxygen, as well as how they would react with water, right? So we will be able to see in this video, we'll be able to observe the way in which lithium reacts with oxygen. If I do not overlay this video with the reaction of lithium and oxygen, I'll simply put the link for the video so that you guys can observe the reaction where lithium is being placed into oxygen and an explosive reaction takes place there. An explosive reaction takes place there, and you are able to see, you will also be able to see the colors, right? The constituent, the different colors with which this group 1, they all have characteristic colors to say. If it's lithium, you know that it burns with a specific color. If you just see a metal burning and you can tell the color, you say, oh, that is lithium that is burning over there. Okay? Right. So let's look at the reaction. I will write the word equations for you. Right? The word equations, let's say for the reaction of lithium and oxygen. Right? Let's say the reaction of lithium, Li, right? Lithium and oxygen. Remember now, when this starts happening, these are ionic reactions, basically. These are ionic reactions. So if you add the reaction, right, this is, someone say lithium solid plus oxygen, which is a gas, right? This is O2, right? But then this gives you lithium oxide, right? This is Li2, right? So now here you need to have 2, and then let's have 4 here. So let's have 4 here, and let's have 2 here, so that we can balance. I just balanced the equation quickly because I haven't balanced it before, but I just need you guys to see. Okay, so if we have lithium, right? If we have lithium, remember initially, let me rub it off. So that you can see how I got here. Right, so if we have lithium and it's reacting with oxygen gas, remember oxygen is always diatomic. Oxygen is always diatomic. Oxygen is a diatomic gas. Diatomic gas. Oxygen is a diatomic gas. The same with nitrogen. The same with nitrogen. The same with hydrogen. These are diatomic gas, which means you always find them either being N2, H2, O2. Same also with the halogens. Okay, right. So when this is the product that you will form this product, lithium oxide. This is the formula for lithium oxide. So it is then your job, it is your prerogative to say, okay, so if it is like that, it's obvious that the equation is no longer balanced. So how do we balance the equation, right? So we need to have 2 oxygens, because here there is 2 oxygens, but here there is 1, right? So if I multiply here, I can't multiply, I can't put the 2 here. I can only put it here, right? It's almost as if it's a triangle error, but it's not a triangle error, it's guided, right? But now that there are 2 oxygens, the oxygens are balanced, right? 2 times oxygen is 1, that's now 2 oxygens. So the oxygens are balanced. But observe, we now have 4 lithiums. We now have 4 lithiums. So now I have to come this side of the equation, and I have to put a 4 so that the equation is now balanced. How do we find this initial product, right? I will hope that people will remember our ionic compounds and how we come up with equation. Right, so lithium has the charge +1, oxygen charge 2 minus. And we say, what we simply do to find the product is we bring down the 2 and we bring down the 1. So you now have Li2 because it's come from there, and the oxygen is also here. Li2, because this one is 1. And when we say if it's 1, when you are asked to say how many Marshalls were there, how many Candiados were there, right? If my brothers were not here, if my brothers were here, we say there were 3 Candiados, right? Or there's 1 more, there are 3, 4 Candiados. But I don't go around saying, this is me, 1 Marshall. Say, who are you? No, it's me, 1 Marshall. I never say it's 1 Marshall, I just say it's me, Marshall, right? But then if it's 2 of us, then I have to say, no, it's 2 of us. There are 2 of us here, right? There are 2 Candiados present. But if it's only 1, I can't go say, yes, I'm here, 1 Candiado, I'm here, right? 1 Richard, 1 Jane, 1 Dediki. No, we don't say 1 Dediki, we don't say 1 Prince, 1 Tino. No, we don't say that, right? We just say Tino Tenda, we just say Elinate. We just say your names clearly as that, right? So this is the product, lithium oxide. So because it is like this, right, then we have to balance the equation. The other important thing is that this is a very vigorous reaction. These are very, very vigorous reactions. Okay? Right? So we also have, so you can write the equations, the same equation for sodium, you can write it, right? Sodium plus oxygen, you will find that the product is the same. The product is the same. And then again, you put that there, again you put that there, and your equation balances out. Your equation balances out. If you use sodium, if you write for potassium, if you write for any other element that you find there in group 1, that equation will balance out. Right. So then you also have reactions of these group 1 elements with water. You also have these reactions of these group 1 elements with water. And they react with water to form what we call hydroxides. They react with water to form what we call hydroxides. So if we have lithium, right? So we have lithium plus H2O, right? They react here to form lithium hydroxide plus hydrogen gas. Lithium hydroxide plus hydrogen gas. Okay? So this is actually the reaction of the oxide, right? That was formed here, right? Let's have lithium oxide, right? Reacting with H2O, right? To form lithium oxide, right? So you guys, you can take the chance. Let's see if you can go about balancing this particular reaction. How would you go about it? Observe that already here there are 2 lithiums. Here there is only 1 lithium. How many hydrogens are the hydrogens balanced out? Here you have 2 hydrogens. That side you have 3 hydrogens. State symbols. State symbols are also important. So this is lithium. The lithium hydroxide is said to be yes. The lithium oxide is what? The sludge. Right? The water It's a liquid. We know that water is a liquid. But then I'm going to leave this one like this for you guys, so you can go and you can balance it. You can balance it as well. Right. So in terms of this lesson, right, we will also look at reactions. You guys should also be familiar with reactions of the group 1 elements when they react with group 7 elements, the halides. Okay, the halogens. So if group 1 elements react with the halogens, you have lithium reacting with bromine, and then you form lithium bromide. Lithium bromide, right? We can even write the equation, because the equations are important. This is chemistry, so equations are important. Please remember to balance this equation. Remember to balance this equation. You will all send me the balanced equation for this particular reaction. Right, so we can also have the reaction of the group 1 element. Again, I will use, let's use potassium now, because we've used lithium, we've used sodium in different equations. So if we have potassium, that is potassium plus chlorine, they are going to react in a very simple way. Potassium, right? Potassium is a solid. Then this is chlorine, which is CO2 gas, right? It exists in this manner. Then we have potassium chloride, right? But Cl gas, chlorine gas, right? Chlorine gas is a diatomic gas as well. Chlorine is also a diatomic gas. So when we write the equation, we must always remember these issues, because they will affect us even when we're answering. That's when you will say, oh, but we never taught these things in class. So potassium is like this, but chlorine, because it's diatomic, it's chlorine gas. It's diatomic, right? So the product now needs to have 2 chlorines, right? It now needs to have 2 chlorines. So the simplest thing is I'll multiply this entire compound that has been produced. I'll multiply it by 2, and this time I'll just say 2 potassiums, right? So 2 potassiums react with 2 chlorines to form the product potassium chloride. If the same also applies for sodium, the same also applies for the reaction with other group 7 elements. Okay, so at this point we have now managed to basically interpret like how elements are arranged in the periodic table. I'm sure by now we are able to outline. Okay, we are now able to outline the physical and the chemical properties of group 1 elements. Right? I said there are several properties for these ones, and you guys have discussed them, and you guys will be able to go and research and look for look at the densities, right? You say look at the melting points, look at how lustrous they are. Are they sonorous? Look at the different physical properties that you will expect of different metals, and see if these properties are also there with the group 1 elements, right? Then we are also able now to describe the reaction of these group 1 elements with water, right, to produce a hydroxide, The same thing also happens with the group 2 elements. The difference is that you guys will look for which one produces between the group 1 and the group 2 elements. You will look for which one is able to produce a soluble hydroxide and which one produces an insoluble hydroxide. It's a combination, the difference between group 1 and group 2 elements. We will not look at group 2 elements in detail, okay? From here, in the next lesson, we are going to look at group 7 elements, right? So in the next lesson, lesson number 2, we are going to look at group 7 elements, right? From there, we will look at group 8 elements, and then we will look at transition elements, okay? Group 8 elements, noble gases, and then we'll look at D block elements, aka Fellaini Versace, no, not aka Fellaini Versace, but aka D block elements, aka transition elements. That's what we're going to look at. Okay, so at this point, thank you guys for listening. Thank you guys for sticking through this entire video. I hope you guys are able to go through the material again and again, so that you can get to a point where you just understand the material. Soon you guys will be back, and you'll be feeling all these Dr. Sidney Memorial chairs, and we'll be able to enjoy our lives again. We're even enjoying it now. Thank you. This is Marshall A.C. Candiado.